So a huge welcome from us all officially. My name is Liz Woodham. I'm a member of the NRICH team here in Cambridge, and I'm joined today by Charlie Gilderdale. Hi, Charlie. And also by Ems Lord, the director of NRICH. Hi, Ems. We're very lucky that we have funding from Trinity College here in Cambridge for these webinars, and so that means they're free to you. So thank you to Trinity for their generous funding. What we're aiming to do this afternoon is to work on some mathematics together. At various points, we'll invite you to contribute using the chat facility. And so what might be useful, if you haven't already done so, is just to make sure that your name is displaying in a way that you're happy, because we may refer to you in nice ways, obviously. So what I'm going to do is I'm going to shortly share my browser window on the NRICH website. But just as a sort of a few words before that, you may be aware that over the summer, NRICH published daily mathematical challenges for students. Now, we decided that they would all be interactive in one way or another, so that anybody working, on their own at home would get a little bit of feedback. And we thought in many ways that perhaps it was a bit of a shame if then nothing came of those interactive challenges. So what we've chosen to do in our current features on the NRICH site is to choose a few problems that were in the summer challenges, but that also link to the curriculum. Now, we've chosen particular examples that we feel don't require specific mathematical knowledge or skills, but instead we hope that they will give the opportunity for you to listen in on your learners' thinking, on their mathematical thinking, and so ideal, we hope, for using at the beginning of an academic year when perhaps you're meeting some learners for the first time. Let's take a little look at some of the tasks. Charlie, before we start mathematics, is there anything you'd like to say by way of introduction that I might have missed off?
I can't think of anything right now.
Okay, that's reassuring. So I am hoping that you can see the browser window. Charlie, would you like to nod at me and just...
I can now.
Fantastic. It's obviously taking a little bit of time. So here is the NRICH homepage. What we're going to do is we're going to look at both the primary and secondary features in tandem today, and we'll say a bit more about that joint working later on. So there are just a couple of problems in each feature, and our aim is to work on all of them to a small extent today. So I'm going to first of all go to the primary teacher homepage using this green button at the top. And we're going to click the link in the right-hand box, which goes to our current feature. And here we go. We're going to kick off today with the sort the street task. So Charlie, I'm going to use you as my sort of guinea pig. You're my student in inverted commas. Have a little look at this picture, please, of the 9 houses in my street. I wonder what you notice.
I notice that some of the houses have got grey roofs and some have got orange roofs.
Right, nice. Okay, and it's interesting that you picked colour as the first attribute there. I think many children would do a very similar thing. Colour kind of stands out at us, doesn't it? It kind of it's so obvious. What about a more mathematical attribute, Charlie? Anything else you notice?
They all have an odd number of windows. So some houses have got 3 windows and some houses have got 5 windows. Oh,
lovely. Now, those of you watching, I'm sure while we've been talking, you've been thinking of your own. I can see a couple of you have posted. That's brilliant. Thank you. Charlie, I'm going to scroll down this page because I want to show you the interactivity that we have here, and I want to ask a slightly different question now. So you've identified a few things you've noticed. I wonder whether you can use any of those noticings or something else to help you sort the houses in some way.
Okay. And are you going to do the sort move? Are you going to move them for me?
I can move them for you.
So I'm not going to. So you don't want me to tell you what my criteria is?
Oh, well, that would add a nice dimension. Okay, yeah. Don't tell us your criteria. Let's see if we can guess it.
Okay, so the one at the top left, I'd like it to stay on the left, please. Bottom left to stay on the left, please. The one next to it also to stay on the left. This one here? Yes, please.
Yeah.
But the one that's above it, can you move that to the far right, please?
Yep.
On the top row, the second one on the top row to the left, please. And the next one to the left. And on the bottom row, the last one, move it to the left, please. And then that one in the bottom with a green door to the right. So I've got a group of 6 and a group of 3.
Okay, lovely. Thanks, Charlie. So those of you participating, can we work out how Charlie has sorted these houses? Pop your suggestions in the chat, please. What's really interesting, Charlie, is that I think some of these ways of describing what you've done are equally valid, but it would be interesting to see what you were thinking about. So having a little look, some people have talked about door position. So I can see that your group on the right have got the doors in the center, whereas the group on the left have got doors to the right. Other people have talked about something to do with a symmetrical arrangement of windows, Becky suggests. I think that is another way of describing the same thing, isn't that? Not the same thing, describing the groups that you have created. Anybody else suggested? Somebody suggests 5 windows. I'm not sure that does describe the way you've grouped them, because we've got some houses with 5 windows in the left-hand group as well as the right. So Charlie, tell us about what you were thinking as you were organising these.
Well, I was ignoring the chimney, and I was thinking about symmetry. So the doors and the windows feeling a symmetrical house front. Yes, unfortunately, there didn't seem to be any chimneys in the very centre. But if we ignore the chimneys, then the houses felt very symmetrical.
Nice. Okay. And so, I mean, we could do all sorts of things with this task from here. We might invite learners to create some of their own images which do have symmetry in total and add them to the mix, for example. We could invite learners to play, in a partner, to do a similar thing that we've just done, or perhaps even better, to play a pair against is not quite the right word, but with another pair, so that there's a chance to talk about what they're noticing. What I think is really powerful about this task is this idea of identifying what's the same and what's different in a situation. That is a fundamental mathematical skill, which we use all the time when we're solving mathematical problems. And this is a really lovely way to introduce that idea to even very young children. Charlie, I don't know if you've got anything to add about the same and different idea, or...
I think it's going to be a recurring theme of our conversations today. Yes.
I think it might well be. The other thing, what I think in primary, certainly, when children are beginning to get the idea of what working systematically might look like, being able to identify what's the same and what's different is a fundamental starting skill to beginning to work systematically. Because if you're working systematically, you've got to have an order. So you've got to be able to distinguish one solution from another, which is about looking for similarities and differences and patterns. If anybody has any particular questions or comments about this task, then do pop them into the chat. Charlie and I wanted to also draw your attention to the fact that in the teacher's resources, so if I just scroll back up and click on the teacher's resources, There are a couple of things that might be useful. You could print off copies of these houses if you wanted children to, you know, physically move them around as they're thinking about their sorting, and you haven't access to the interactivity. You might also be interested in having a little look at this task, which is called sets of numbers. And Charlie and I were having a chat about this the other day, and we thought that this actually could lend itself very nicely to looking for what's the same, what's different, but here in a purely numerical context. Now, you'll notice that, of course, the numbers that we've offered here are not suitable for very young children, but I'm sure you could create your own sets so they would be using the same skills. We don't have an interactivity in this one yet is the appropriate word, but I guess it wouldn't be too hard just to write the numbers on pieces of paper so children could physically sort. Charlie, anything you'd like to add about our sort the street task before we move on?
No, but sets of numbers, it seems to be a nice follow-up, and I can see some square numbers there. I can see numbers which are, I don't know, 1 less than multiples of 4, 1 more than multiples of 4. There are all sorts of different criteria that one could be using to separate sets of numbers and get students thinking about what's the same about all the numbers in one group and what's different between those numbers and the numbers in the other group. So getting students to work in pairs, think of a criteria, separate the numbers into 2 groups, and get their partner to work out what are the criteria that were used to separate the numbers. Seems like a really good activity.
Absolutely. Thank you, Charlie. Okay, so let's go back. This was our sort the street task. Now, just as a quick reminder, as I say, this is in our current feature. It's actually a live task at the moment. So if you do have a go at this with your children, with your learners, do drop us a line, drop us a message about how they got on, the kinds of things they were identifying, the ways they were working, if you can. Our submit a solution contributions don't necessarily have to come from individual children. They could be you as the teacher summarising what children have done.
Sometimes teachers send us photographs of what the children have displayed on the classroom display board, which is great to see and great to include in our solutions. Absolutely,
and this particular problem lends itself very well to that kind of display. So what I'm going to do now is we're going to, rather than have a look at the next primary problem, the other primary problem, we're going to now look at one of the secondary tasks, because I hope, as you'll see, Charlie and I felt that this next secondary task linked very nicely to sort the street. So I'm going to leave that window open. I might go into a new tab. Here we go. Let's go to the secondary teacher homepage. So that's up here, the dark green button. Similarly, the right-hand side, we're going to go to the latest feature. And the task we'd like to share with you first is called frogs. Now, as this is the secondary task and Charlie is the secondary coordinator, Charlie, I'm going to hand over to you. And I'm maybe thinking you might be getting me to do some work this time.
Yes, I will. Okay, there's a video which we don't need to bother with today because we'll be able to explain the task. And you can click on the full screen version
of the interactivity.
Of the interactivity.
Yeah.
And to start with, you have 2 pink frogs that are going to be moving from left to right, and you've got 2 blue frogs that are going to be moving from right to left. And the idea is to get the pink frogs to the right, the blue frogs to the left. And they're only allowed 2 types of move. If there's an empty lily pad, so to speak, in front of them, they can slide onto it. So there's an empty space. So to start with, you've got a choice. Either the pink or the blue frogs can slide into the empty space. The other move that's allowed is that a frog can hop over one other frog. It can't hop over 2 frogs. It can hop over 1 frog. And the challenge is always to do to get everything, the frogs to the other side in the least number of moves.
Ah, right. Okay,
So,
that's an added challenge. I mean, just swapping them is one thing, but doing them in as few moves as possible. Okay.
so the challenge, Liz, is I happen to know that it should be possible. It is possible to get them all across in just 8 moves.
Oh,
So,
really? Okay.
No pressure.
Right. All right. Well, let me have a go. I'm going to start by moving this pink frog into the middle. As you
All you
said,
need to do is click on it and it'll move.
click. Yeah, I could have used. That was my choice. I could have moved the blue. Okay. So now let's do a jump. Okay. Right. If I move this one over as well. Okay. Let me try doing the hop. That seems to be the obvious point now. Okay, well, the only thing I could do now is move the blue and, I'm not sure I've done this very sensibly, Charlie. I seem to have got these 2 pink frogs bunched together. I've got a trapped blue frog. I can't move my trapped blue frog now.
It can't hop over 2 pink frogs.
It can't hop over 2. Okay. Can I go back? Can I?
If you click on the blue frog that's on the left.
Oh, yeah. Okay, it's gone back.
And then the pink
that
frog
one
that was behind.
Okay. So maybe at this point, I should have done something different, perhaps. So rather than moving my pink frog to the right, what would happen if I moved my blue frog to the left? So this is good. I haven't got 2 of the same colour together. So if I jump now, I'm going to jump this other pink. This is looking a bit more promising. Slide the blue, jump the blue, slide the pink. Oh, I did do it in 14 moves though.
Okay, but that was your first go and you were learning, so that's
very generous of you.
So do you want to do the same, but this time with 3 frogs on each side?
Okay, I'll try.
And what I might do, I might go making a note of your moves as you go along. That
would be helpful because I'm thinking that it would be useful to refer back to what I've done, maybe. Okay, yes, please do. So I'm going to put 3 on each side. Okay. Right.
So I'm going to use S whenever you slide a frog.
Okay.
H whenever a frog hops.
Okay. Okay. So those of you participating, you may wish to help me along, do some suggesting. You may just want to watch and think about what you would do. You may want to think about what the total number of moves might be. Okay, Charlie. So I'm gonna start with a pink slide.
So I'm going to write S in pink.
Oh, nice. Okay, yeah. Then I'm going to do a blue hop, I think. Okay. So I think at this point, I'm going to have to move this blue. Otherwise, I'm going to end up in the same situation as before and have too many bunched together. So I think I'm going to do a blue slide. Then a pink hop. Thank you for the help that I'm receiving. Okay, now it feels like I need to do another pink hop. And then a blue slide. No. Because that's going to mean I'm going to get 2 pinks bunched. Oh, no.
Or 2 blues bunched.
Yes, sorry, that was a mistake. So I'm going to do so not the blue slide, I'm going to do the pink slide. I should have learned from my mistake earlier. Okay. Then a blue hop. Then another blue hop. Then another blue hop. And then we're going to do a bit of shifting, I guess. So a pink slide, a pink hop, a pink hop, blue slide, a blue hop, and a pink slide.
You went a little bit fast there for me.
Oh, I'm sorry, Charlie. Oh dear. Oh, we can replay it though. Can we replay?
Well, you could start again.
Yeah. And this time I can make sure I don't make that mistake again.
Because a number of moves, then we can see whether you can do it in the minimum number of moves.
Okay, so we've got 3 and 3, right. So we're doing pink slide, blue hop. Then we're going to do the blue slide, the pink hop, the pink hop. Now at this point, I need to do my pink slide, yeah. Then we've got blue hop, you've already got this one. You've got the next blue hop, next blue hop. Yes, yeah, so then it's a pink slide.
Okay, just a minute. Yes.
Yeah. Then a pink hop. Then another pink hop. Then a blue slide. Then a blue hop. And a pink slide.
And that's taking 15 moves, which I happen to know is the minimum number of moves. When
it tells me that as well, so it's given me that feedback, which is useful. Okay, I'm interested, Charlie, the way that you have recorded here is quite interesting. The colour is really useful. I'm kind of sensing some symmetry going on here. Those of you participating, do you notice anything from Charlie's annotations?
Actually, below, I'm going to ignore the color and I'm just going to write your moves in the order that you did them.
Okay.
So it was a slide, a hop and a slide, then 2 hops and a slide, and then it was 3 hops,
yeah,
and then it was a slide and 2 hops, and then a slide and a hop,
yep,
and a hop to finish off with.
A slide to finish off.
Sorry.
Yeah. So yeah, thank you for your comments in the chat. Again, it's interesting to see that you're finding different ways to express the pattern that you've noticed. Andy suggests it's symmetrical around the middle move. Could you mark the middle move for us, Charlie, on your annotation in red there?
Okay.
Please.
So this is the middle.
Right. Yes, so we can see quite clearly, kind of bouncing out from the middle, that you're absolutely right, Andy. We've got this symmetry. Some of you have expressed it slightly differently. Anne is saying it's like a palindrome. Exactly, a palindrome is a number which is read the same forwards as backwards. And Ian is suggesting that the same sequence of moves is coming in from both ends, which is another way of saying the same thing. That kind of feels intuitively right, I think, because of the symmetry in the number of frogs we've got on each side. We've got 3 frogs. I'm not sure that symmetry would hold if we had different numbers of frogs on each side, but it does seem to make sense intuitively that we have that symmetry. Charlie, what are you writing up now?
Well, it seems useful to be thinking about being able to predict how many moves it would take altogether.
Yeah.
We know that it took 15 moves here.
Yes, for the 3 and 3.
And before it took us 8 moves. We can count here how many slides, 1, 2, 3, 4, 5, 6 slides. And so the hops, there must be 9 hops. We didn't pay attention to it, but I think it's 4 slides and 4 hops when you have 2 of each type.
Okay.
So we could be asking students to be thinking about what they notice, about how the number of frogs determines the number of slides and the number of hops. Can we predict how many moves there are going to be in total when we have 4 on each side or 10 on each side? You know, if you go back to the number, you can increase the number to a lot more than 3.
Up to 9.
And on the other side, you can also,
similarly. Yeah.
So, yeah, students can have a go at using, I mean, this is the value of keeping a record of what you do. I've done the problem before, so I know that this way of recording is quite useful. Students won't be expected to do anything like this to start with, but it seems to me that it's quite good to let children develop their own way of annotating and then discuss the merits of the various ways and come to sort of appreciate ways of doing this that highlight, in particular, the number of slides and the number of hops. But this also sort of seems to highlight sort of the pattern there is, doesn't it? It's sort of a slide followed by hop slide, followed by hop hop slide, hop hop hop. And then we sort of go back, slide hop hop, slide hop. I haven't checked, but I suspect that if we had 4 on each side, it would do something like slide, hop slide, hop 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 slide, hop 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 slide, hop 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 hop, slide hop hop hop, slide hop hop, slide hop, slide. Now, just being able to sort of, whether I'm right or not, is the fact that I've got a conjecture, that I'm looking at a pattern, that I want to there's a bit of me that says, come on, Liz, put 4 frogs on each side, and sort of, but you know, and that's the kind of thing that you want the children to be able to do, to notice that there's a pattern here, and to be checking their pattern, and then later on perhaps justifying it, because it seems to me that the number of hops looks like it's, in the first case, it's 2 times 2, and then it's 3 times 3. And I can think of, oh, if I've got 4 blue frogs on one side and 4 pinks, well, each one of these is going to have to hop over each one of these. So I think there are going to be 4 times 4. There are going to be 16 hops. So I can sort of see why it's going to be 16. And perhaps each frog slides once. I don't know. Maybe that's why. I don't know. I haven't checked. But the fact that the problem raises these questions, and so this is a reason why we thought that this was a good problem to have at the beginning of term. You start the term with an activity that requires some experimenting, some exploring, some conjecturing. Nice activity to do in a class in groups of 2s or 3s. If you haven't got the interactivity available, can I share my screen for a minute, Liz?
Yeah, please do. I'll stop sharing.
So in the teacher's resources, we've got printable worksheets. So students could be given printed versions of the sheets, and they can do, you know, what Liz was doing, but do it with counters, moving the counters as if they were frogs. And then there's the possibility of having 3 frogs on each side. And I think we've got even bigger sheets here. So you can have 4 frogs on each side and 5 frogs on each side. But I've known students get very excited about this and having big long sheets of paper, very long sort of flip chart sheets, and doing 20 frogs on each side and getting very so and having having to be really careful to count correctly, and because they have conjectures which tell them how many they're going to have. Okay, I'll stop sharing.
Thanks, Charlie. Okay, so we hope you enjoyed, you know, having a little think about that task, and we felt that hopefully you can see that we felt the Sort the Street and the frogs activities had similarities. They had common points, partly about the same, different in both, but also about, you know, trying things out, as Charlie was saying, experimenting, looking for patterns, which in the frogs case then goes on to making predictions. So we felt that they were a nice pair. And as Charlie said, the frogs task, although it is a secondary task on the NRICH site, the level of mathematics is such that many primary children could have a go at that as well. So let's have a look at our third task now. Let me share my screen once more. Here we go. Charlie, can you see the frogs interactive again now?
I can.
Fab. So what we're going to do now is we're going to go back to the primary feature. So here we Sort the Street. We'll go back. Oh, whoops, too far. There we go. So here are our tasks. We've had a look at Sort the Street. So the other one that we're offering is called Polyplug Rectangles. Now, in Polyplug Rectangles, Charlie, I'm going to ask you to have a little think about this one. And of course, those of you participating, please do feel free to offer Charlie support via the chat. Monkey has hidden a rectangle on this 5x5 grid. Now, just to be clear, by a rectangle, we're actually talking about a rectangular array of spots. So we're filling the whole rectangle. We're not just using an outline of a rectangle. So in the interactivity here, we're told that Monkey has used 6 plugs or 6 spots for this particular rectangle. We've got to try and find out where the rectangle is on Monkey's grid. And we're going to do that by guessing a place on the grid, and then Monkey's going to give us feedback as to whether it is part of the rectangle or it isn't. Now, in a similar way to frogs, we are trying to do this, ideally, in as few guesses as possible, Charlie. So that's a sort of an added level of challenge. You choose to accept that challenge or not. I think I know what you're going to do. But so here we go. Where would you like to test first, Charlie? Or if there's anything you'd like clarifying, please shout. Okay,
so if it uses 6 plugs, it's going to have to be a 2x3 array. And presumably it can be either landscape or portrait. So
how do you know it's going to have to be 2x3?
Well, because 6x1 is too long to fit in your 5x5 grid.
Yeah.
Okay. And so I could see at the top there are 3 different positions I could have this in landscape, but also I could also have it in sort of 4 different positions in portrait, and I could go down. Goodness, there are lots and lots of different positions for the rectangle. If I chose a corner piece, it's very unlikely. There are very few of those rectangles that are. So I think it might make sense to choose a center, center one as a start.
Yeah. All right. Let's see what Monkey says. Oh,
go for a low-hanging fruit.
Well, you've in this case, it was a good choice. Monkey is saying yes, that spot is part of my rectangle.
Okay, so it could be either landscape or portrait at this stage, and it could be to the right or to the left. It could be above or below. I've got no idea. I think I'm going to go for the circle just to the right of the one that I chose earlier. Yes.
Okay. No, unfortunately not.
Okay. So I now know it's either landscape, and that ticked circle is either the bottom right corner or the top right corner.
Yep.
Or it's portrait, and that circle is either the bottom right, the middle right, or the top right. Okay, so there are 5 possible rectangles.
I agree.
And oh goodness, I'm tempted to go diagonally to the, oh, wait a minute. So whatever happens, the circle on the left of the tick is going to be in my rectangle.
Ooh, nice deduction, Charlie. Yeah. So what are you going to do then? Are you aiming for the fewest possible guesses? So you're going to not waste a guess?
So I'm not going to tick on that because I know
Okay.
that that circle must be, of all the rectangles that circle must be in both the landscape and it must be in the 3 portraits. So that's a given. I'm not going to tick on, I'm not going to check on that. That must be in my rectangle. I suppose I want to know whether I'm going to go up or down. Gee. Okay, I'm tempted to go diagonally from the tick, up diagonally.
This one?
Yes, from there, yes.
Yeah.
Yes, please.
Ooh, you're in luck. So how many of you narrowed it down to now, Charlie?
Well, so it could be landscape,
Mm-hmm.
with the first tick being in the bottom right,
Yep.
or it can be portrait, and there are 2. So that new tick could either be the top left or the middle left. This feels a little bit like, I'm thinking of a number between 1 and 100. And yes, trying to narrow it down. I don't know what
you are being very strategic as well, of course. I think when children first have a go at this activity, particularly younger children, they like to see the ticks. So you're taking it very seriously that you prefer to guess in as few as possible. I can imagine at first children will like to have the reassurance that a spot is part of the rectangle.
Okay, so the circle above the first tick, I know is going to be in the rectangle.
Agreed, yeah.
So now we know for sure 2 of the circle, the other. So yes, so like there's a 2 by 2 array that we know is going to. And I just need to know whether to go up or to the left. So I'm going to go to the left of the latest tick, please.
Okay. Ooh, no.
Okay, so now I know it's portrait.
Yep.
But what I don't know is whether it's at the top or in the middle. So now it doesn't really matter what I do. So I can either go for one of the circles above or one of the circles.
How many more guesses do you think you're going to need, Charlie?
I'm going to need 1 more guess and then I'll know exactly. Okay, so if I go to the circle below the original tick.
Yep, this one here.
And whether that's a tick or a cross doesn't matter. That will tell me. All I need to do is click on that, and then I'll know where the rectangle is.
There you go. You have your solution.
So I think it's portrait at the top, 1 away from the left-hand column.
Okay, so you're ready. You think you know where the rectangle is. Should we tell Monkey that we're ready?
And it's interesting that the crosses are just as useful as the ticks.
Absolutely, absolutely. And you're absolutely certain, Charlie, you know where the rectangle is?
Yes.
Okay, so we're being asked to show where it is. So if I highlight this, is that where you're thinking, Charlie?
It is.
Well done. Absolutely. Very nicely demonstrated, Charlie. You were, I say, you were very methodical. You were really trying not to waste any guesses, which children wouldn't necessarily do straight away. I've watched quite young children have a go at this, and they get really excited when there's a tick. So part of the activity for them is getting that positive feedback to confirm their thinking. So you can gently move them towards that reasoning that states that actually you don't need the tick to be sure of the position of the rectangle.
I can imagine getting two children playing against each other and taking it in turns to be the monkey and to be the guesser, and keeping scores of how many goes they need to have a go at before they can be certain of the rectangle. And if they do that and they keep a record of how many guesses they needed, so I needed 5 guesses there, they could then, in a way, each guess is like a penalty, and you want to minimize the amount of guesses, and then you play the game 10 times. I imagine that would focus the mind and get them to think as strategically as possible.
Yes. I think you're right, Charlie. And just very quickly, in the teacher's resources of the task, as in the previous ones we've mentioned, there are printable versions. So you can print out a 5x5 grid, which you could use with counters, or you can print out a sheet which has got 6 little versions of the grid, which you might use to record your own one for a partner to guess, but also you might use it to mark what the partner has given as feedback when you're trying to guess theirs. So those things are available there. Just to go back very quickly to the interactivity, if you click on the top right cog, you can change the settings and you can choose the number of spots should you wish. 6 is a nice one in the sense that it's, as Charlie realised, there are quite a lot of places for a 6 plug rectangle to go. So it involves quite a bit of reasoning for narrowing it down. But obviously you can have some lovely conversations about the larger grids, the larger rectangles, I beg your pardon, because larger sometimes indicates harder to children, where actually it's slightly counterintuitive. Of course, a larger rectangle is actually easier to place on our 5x5 grid. So I think, Charlie, we've got time to have a look at one more task. So this next task we chose, and we think it links rather nicely to the polyplug task that we just had a go at. So for this, we're going to go back to the secondary feature. So let me go back here. There's our frogs problem. Here we go with the secondary feature, which of course I could have also got to using the top button here. And the one we haven't looked at yet is called treasure hunt. Charlie, I'm going to hand over to you again, and I think it's time for me to do some mathematics again, isn't it?
Yes, and yeah, funnily enough, Liz chose a problem which involved hiding something, and I happen to also, for the secondary feature, choose a problem that involved hiding something. So Liz was hiding rectangles, I'm hiding treasures. And Liz, you need to use coordinates to help you find the treasure. You've got a square grid. It's a bit like a street map where all the streets are parallel or perpendicular to each other, and you can only travel along the streets from corner to corner. And when you choose a point, you'll be told how many sort of blocks away you are from the treasure, okay, assuming that you travel in as direct way as possible.
Right. Okay.
So choose a starting point where you might think the treasure will be and go from there.
Okay, okay. So I don't know whether those of you watching have got some suggestions for me. I guess. So my first instinct is thinking about what you did with Polyplug. You went for the middle, which always seems, you know, quite a sensible thing to do. I wonder whether perhaps I should try the middle and see what happens. Yeah, okay. So we've got a 12 by 12 grid. So the middle will be 6, 6, I think. I'm going to type in 6, 6 and test those coordinates. Okay, so I'm told that it's 11 steps away. Right. So let's imagine I'm going to...
Liz?
Yeah.
11 is quite far. I'm just going to cheat a little bit. Do you want to just click
Okay.
on new game and
Okay.
do the same again and see whether you get
Okay.
a treasure that's a bit closer?
Just so it takes a little bit less time.
Yes.
No.
Okay.
Try again.
You have to click on new. Oh, yes.
Okay, 5. That's a bit easier, isn't it?
That'll be slightly easier.
This will take us slightly less time, so it's in everybody's interest. 5, right. So
you could go 5 steps north, so to speak.
Yes,
and the nice thing about the interactivity is if you do that and click on that spot, it'll leave a mark. Or you could have gone 5 down, south.
5 south, yep.
And likewise, you could have gone 5 east,
yep.
5 west.
Yes, I could. Okay.
But you can also go, say, 4 west and 1 north.
Yes. Okay. Or I could go sort of 2 north and 3 west, or I could go 3 and 2, etc. Okay. I think I'm kind of understanding what sort of, where my possibilities are, Charlie. This is looking like I'm going to have a square here. Let me just okay, so if I go 4, 1, yeah, this is going to be a square. So I think I'm going to have these possibilities that are 5 steps away. Please just check that when I'm clicking is correct. I think that's right. Just check that one, 4 and 1. Okay.
So this is, if you didn't have a grid, you'd get a circle with radius 5.
Yes.
But this is slightly different kind of geometry. We sometimes refer to this as taxi cab geometry, because you can imagine being a taxi cab in New York and just being able to drive up and down streets that are parallel or perpendicular to each other.
Mm-hmm. Okay, so now the idea is that I choose another coordinate to try and narrow down the possibilities. The question now to me becomes, do I actually select one of the possibilities because it might be the right one, or do I enter something that's not actually a possibility already? Let's see. What if well, I think what I'm going to do is just choose another place on the grid and see what happens. So I'm going to try, let's try 4, 7. 4. Oh no, I didn't try 4. 4, 7. 4 away. Okay. So presumably I can now create a similar kind of arrangement. Let's see. No, what I don't know if it's useful, Charlie, for me to put these as spots, because
yes, I think it is, and we'll see where they overlap.
Okay. So that's 2 and 2, and then that one is 1 and 3, and then we've got all the way over here. Oh, hang on. We've got this. I think that is 4.
Yes.
And then we've got 2 and 2, and this one, and this one, and this one.
Yes.
So I think these 4 points here so far are common to both.
And then if you carry on,
then we've got this
northeast.
This. Yes, am I doing this correctly? This is 4 that way. No, went too far. Oh no, I didn't.
No, you didn't.
No, it was correct. That and that. Okay, so look, we've got these points here.
And there's also one where the 2 there. That overlaps both squares.
You're right. I had to convince myself of that. Thank you. Okay, so now what shall I do? Help. Those of you watching, what shall I do? Any suggestions for me? It's gone quiet. I might have to make my own decisions. Okay, that's a good idea, Nicola. Yes, let me do that. I'm going to get rid of the non-overlapping ones. so that we can narrow down. It's easier to see. Very good idea. Thank you. Now, this is where it gets trickier. We've got this and this, so not these. Am I correct here, Charlie?
Yes.
Is that correct?
I think the one to the right of the 5 and
Oh,
below
thank
the
you.
5, but leave the one at the very end.
That's it. That's it. Okay. If you choose one of the mutual points, then you'll either be correct or you'll have one option. Choose one of the dots you're left with. Oh, this seems to be the advice. Okay. All right.
If you choose 2, 5, and you're told you're 2 away, you wouldn't know whether you need to go up or down.
No, you're absolutely right, Charlie.
If you choose 4, 3,
yes,
then you're going to get a different number of steps
for all of them.
For all of them.
Yes, I think that's really useful advice. And Alicia is saying one of the end ones or the northmost point. So yes, right, okay. I think that is sound advice. I'm going to go for 4, 3. See what happens. 6 steps away. Okay, so where does that take us? 2, 3, 4, 5. This one.
Yes.
So I think the treasure is at 1, 6. Let's see whether we are correct. You found the treasure. It took you 4 guesses. Oh, can you find the treasure in fewer than 4? So I clearly wasn't as strategic about that as I could have been. Interestingly, some of you on the chat are alluding to this already. I wonder at the very start, Charlie, whether I could have done something a little bit different.
Well, I think we just leave that as homework for everybody to think about.
I think so too.
It is possible to do this in fewer than 4 guesses every time. And if you go to the purple cog and show that there is also a level 2 problem, a level 3 problem, and level 4. So the level 2 problem has got negative coordinates, so it's much the same as this one. And again, I think you could do that in fewer than 4 goes. Level 3 is slightly trickier because you're only allowed to guess outside the pink region once. And I think you can do this in under 5 guesses, but really challenging is level 4. So if you want to show level 4, this is the 3-dimensional version of the treasure hunt. So not only have you got to work out how far across and how far along, but also how far up to go. And surprisingly, it can be done in fewer than 5 goes, I think it is. Or was it 5? I can't remember. It's either you can do it in 5 goes or fewer every time. So
it's surprisingly small, though, I think. Yes.
Yes. So there's a challenge for everybody and for your students. And
thanks, Charlie. So I hope you can see that those two, the polyplug task and our treasure hunt task, we felt would really complemented each other because this idea of encouraging students to think strategically, and in those 2 instances, the strategic thinking was sort of encouraged because of the fewest number of guesses. This idea of trying to get the smallest number of guesses really focuses students' attention and encourages them to use their strategic thinking. So we're rapidly coming towards the end of our webinar. We hope you've enjoyed the tasks. We'd like to just share with you a few other links on the site very quickly, just to remind you of other resources. First of all, you may have noticed that when we've been looking at any of those 4 tasks, there are some sort of these what we call lozenges on the left-hand side. In this case, actually, the treasure hunt task is linked both to the primary and secondary curriculum mapping documents. If I just click on one of these, just so you get the idea, this is the primary page, but the secondary page is analogous to this. It shows, it gives you a link here at the top, if you're teaching in England, to this Google Sheet where we have mapped NRICH tasks onto curriculum objectives. We want to emphasize this is work in progress, and one of the things that we are devoting time to in the coming months is really making sure that our mapping document can be as good as it can be as helpful as it can be. And obviously that will take a long time, but this is one of the reasons for structuring our features very slightly differently, and more on that in a moment. We kind of presume that the fact you're here means that either you are signed up for our newsletter, our email newsletter, which you can see I've scrolled right to the bottom of any NRICH page, and you get this link in the bottom right to sign up for the email newsletter, or perhaps you follow us on Twitter, where we also publish our latest news and details of future events. So please make sure you're kept up to date by either of those messages, either of those, what's the word I'm looking for, either of those means. As we've been talking today, we've been referring to the current feature, but you may like to take a little look at our previous features. I'm happy to be on the secondary page here, but again, there's an analogous primary page. It takes you to all the previous features we've published, each of which have a particular theme. So do take a look there. This recording of today we will pop up on this page here, NRICH.maths.org/NRICH-live-SEP-2022. Now, we've already put up a PDF copy of the PowerPoint slide, which contains all these links that I'm showing you now. So if you're not quite sure what we've said, do click on that because it'll remind you of the links. When we have got the recording, we will publish it on this page. And just in case you don't remember where that page is, if you click on our events page, there is a link here which will take you to all the previous recordings. And so once we have updated the recording of today, we'll also, oh dear, I clicked on entirely the wrong one, this one here. Once we have got this recording up on the site, we will put a link on that page too. You may have noticed that this webinar has been slightly different from previous ones. As we said at the beginning, we've had both primary and secondary colleagues together. So Ems has already put up a link to the feedback form. If you have, we welcome all feedback, but if you have any particular comments about that aspect, we'd be interested to know. Our future webinars may vary. We're not quite sure. We wouldn't want to tell you that they're all going to be primary and secondary together, or they're all going to be separate. It will depend on the tasks. So you will have noticed that our features have had fewer tasks compared with previously. That's because we're going to start to do features more regularly, so more frequently. So from now onwards, we're going to publish new tasks at the beginning of each month. So the first Monday of each month, and they will be live for 3 weeks. And then at the beginning of the following month, we'll publish a set of new resources. So there'll be fewer tasks in a feature, but there will be more features throughout the academic year. So sometimes the features might lend themselves very strongly for a primary and secondary joint webinar, and sometimes maybe not so much. I think I have talked enough. Charlie, is there anything you'd like to say before we sign off?
No, I think everything that was on our list of things to say has been mentioned.
Good. Okay. Well, thank you so much for your participation, all of you. We hope you've enjoyed the session, and we look forward to seeing you again on a future webinar. Thank you very much.